All right, so we're on to the next. Yeah, let's just jump right into it. Let's go. Keeping it mellow through surface area. So there's our definition one more time. If you look in your text, you're not going to find anything but this formula. It does actually have a line with something else, but what happens when the problem looks as such? We want to find the area of x is equal to the square root of 12y minus y squared. On the closed interval from 2 to 10, we're talking about y's, and we're revolved about the y-axis. Well, the formula given to us, that's about the x-axis, where everything's in terms of x's. Can you come up with a formula? Can you get it? The surface area, again, I like to write SA instead, is you just replace it from C to D. They just like to use a different number, and then 2 pi. Now, don't write f of x. We're going to write in g of y times the square root of 1 plus g prime of y, all squared, dy. Because we're going to go about the y-axis now instead of the x-axis. Everything needs to be in terms of y. Or, excuse me, wow. Or, shoot, you could have just done the problem and been like, that's y, that's x, that's x, that's x, and we're going about the x-axis. It'd still be the same thing. Now, there'd be exceptions where that wouldn't work out that way. Like I give you everything in terms of x's and then have you go about the y-axis. That won't happen, don't worry. I'm not thinking about making this tricky. But there's our formula. So a couple different ways of thinking about it as to how we can set it up. So let's get after it. Same types of problems as before. Let's get it. So I'd like to change this x and just call it g prime of y. Or g prime, just g of y. And then we need to plug into our formula here. So first thing we're going to need, actually let me leave that right there. Cool, we're going to need our g prime of y. So g prime of y is going to be equal to, so that's 2 roots of blah goes down here, and then we multiply by the derivative of blah up top. Let's clean that. There's a 2 in common. I can see it. Those go away, and then we have our g prime of y is 6 minus y over the square root of 12y minus y squared. But, hey, dude, we don't want just g prime of y. We want to square that bad boy up. So g prime of y all squared is going to be 6 minus y all squared over 12y minus y squared. Okay. Let's go. Let's plug stuff in where they go. So we're going to say our surface area is equal to, I like yanking that 2 pi out. Why are you going to leave it inside there? Why are you going to leave it inside there? Remove the noise. And then we have from our C to our D, right? When we're in the Y's, we call it C and D. It's A and B. Who gives a shit? They're just numbers. They're just letters. It's from 2 to 10. And now we're going to put in our G of Y, which is the square root of 12y minus y squared times the square. Oh, we have a square root times the square root. And then we have 1 plus, and then we put in our g prime of y, which is 6 minus y all squared over 12y minus y squared dy. So, all right, I think we're ready to go here. There was our scratch work off to the side. Now, I've never done this problem before. I actually just chose it out of the textbook and kind of went down to some of the tougher problems. So I don't know how this one's going to turn out. I think there's some times when you watch teachers, especially math teachers, do problems. We already know the conclusion. We have it memorized. We know all the steps, which makes it seem very simple. Well, simpler. But that's not always the case. Like, I'm looking at this problem and I'm wondering, like, do I want to do a U sub? Because my gains are one of these. I can maybe put all this stuff together and see if there's a U sub. Or I could use the fact that there's a square root on both of these and I just put them together. And that's the direction I'm going to go, but I don't know whether that's going to work or not. I don't know until I try. So that's kind of the game here. Where I'm like, I think I'm just going to bring it together. And I'm going to hope for the best and hope there's a perfect square in there. And if there's not a perfect square, we're screwed. We go back and we try and figure out a U sub. So cross your fingers. Let's hope this works. So the integral from 2 to 10. And again, I'm just going to use the fact that they both have a root. So it's 12y minus y squared times 1. Yeah, I think this is the way to go. It seems like it just because these are, because this and this are going to cancel, so I'm guessing that's the way we should go. Let's find out. So we'll place that there, and we'll place that there. Yeah, it's got to be this, isn't it? So 1 times that stuff is that stuff. And then when we bring it in over here, they just cancel, leaving us with plus 6 minus y all squared dy. So what's that going to be? We're going to lose a term. Yes, this is going to work. This is going to work. This is going to work. Come on, please work. Please work. Please work. So 2 to 10. Now we got to expand that thing out, figure out what's going on. So we got 12y minus y squared. And then we expand that out. Was that 36 minus 12y plus what? Really? Come on. No way. Are you kidding me? I love this problem. This is great. I can handle this all day long. Oh my goodness, we're left with the square root of 36 dy. Yeah, buddy. So that's just 6. So we ended up with 36 pi 2 to 10 of just blank. Now we got to leave something in there. Sorry. Square root of 36 is 6. Ah! I suck. Dang, I got all excited. Sorry. Get all fired up. I'm like, look at this. I figured out the problem. And I couldn't do math. Golly. Well, that's just 6. And 6 times 2 pi is 12 pi. Now, I'm going to write it in here because, well, you can't leave it blank. You know what I mean? You're like, it's that squared. You're like, what squared? You got to have something inside of there. I know they can, sometimes they'll just write it as the integral of dy. I hate that bullshit. So what's going to happen is we're just going to pick up a variable. We're just going to pick up a variable. That's a number. So it becomes 12 pi y evaluated from 2 to 10. So we get 12 pi times 10 minus 2. So this is 12 pi times 8, which is 96 pi units squared. Wow, that worked out nicely. So maybe sometimes it's u sub. Sometimes you're going to need to just put the roots together. I'm thinking more often than not, you're going to put the roots together and these will be cooked up to just fall out. But sometimes you got to have u subs too. Huh. But you're pro with u subs. All right, that's it. I'm done. I don't want to talk to you anymore. I'll see you in chapter 7 where we learn all of our integration techniques. If that's the order we're going. Who knows? Maybe we'll change the order. All right. Appreciate y'all. See you.